Alright guys, so today we're doing a LS400 1UZ VVT-i to an Altezza, the AS200, the 1G-FE plug-in. So let's get into it. Okay, so as discussed, it's going to be a LS400 1UZ VVT-i into an Altezza. In this particular case, the customer had inherited the car, bought the car, and someone had already gone and messed around in the ECU box trying to get everything to work. So we had to do a complete hardwire. So you can see we've got the entire interior harness of the engine bay going inside the vehicle, so we can get that all done. So as you'll see, it's now actually hardwired into the car. So there's no sort of patch harness or anything on here, straight hardwired in, and we've added a plug in here to get all the bits and bobs across that we needed to into these plugs over here. What I'm going to do now is we're going to take you through the build process and show you. Obviously we strip everything down, we build a whole bunch of new sections to go in, so we'll go through that now. Okay, so that's what we basically do as we go through everything. So to start off with, what we're going to do is we're going to go through the particular layout. So in this case, because it's a hardwire in, the customer is going to refit this entire engine bay harness into the vehicle. These three body plugs are now actually part of the engine bay harness. They're no longer part of the engine harness. So you'll see the engine harness completely disconnects out of this box here. This is obviously in the front of the vehicle over here. So for these purposes, we just got it here because we had to fit the whole entire engine harness on the bench here to do all the testing. But basically, inside the ECU box, you've got your three plugs that are going to form part of your engine harness. You've got your three plugs that will form part of your body harness now from there. You've got your gray plug, you've got your black plug, and we've got this new DTM 6-pin plug that we've added in to get the signals across. Coming out along here, then you're going to end up coming to the back of the harness. So down here, you've got your black piece of plastic over here. And you'll see you've got mounting points there, you've got a mounting point there, and you've got a mounting point there for this back piece. Obviously this is a 3UZ engine, so these two mounting points are missing in this particular one, but on a 1UZ VVT-i they are actually there. So starting from the back piece of plastic here, we'll come down the front, so it's going to come out here, which is then going to go into this piece of plastic, which mounts on there and there. And coming out of the back hole over here, the first one is going to be your coil 7 and injector 7. Remember, this is the left bank, so it's 1, 3, 5, and 7. The second hole that comes along, you're going to have your coil 5 and injector 5. The next branch that comes out over there is going to be injector 3, coil 3, and your cam sensor for the left bank. And then coming out of the front over here is going to be your noise filter, which bolts onto the noise filter, which is on your engine over here, and that bolts down to there to get an earth. All right. Coming along here, you're going to have a breakout here, which goes to injector 1, coil 1. It goes to the oil control valve on the left bank. Also breaks out to your TPS sub-harness connector. So remember, there's your TPS, and this is a little sub-harness built into the throttle body that plugs straight into there. And then we've also got your pedal position sensor. Remember, this is drive-by-wire, so that's actually a pedal position sensor. And coming a little bit further down here, then it's going to break out here to go to your drive-by-wire motor. So that's your motor and your clutch wiring in there. It's also going to break out to go to your cam sensor on the front of the engine here. And again, you've got these little mounting holes here and here for your harness to sit in there. Then coming down here, it's going to break out and it's going to go off to the air conditioning pump, which will go over here. It's also going to break off to go to the oil pressure switch. Now remember, this is an LS430 engine, so on an LS400 this is obviously moved back to here, and the oil pressure switch is sticking out the back there and so that would then just come straight down there, go through there. Then what would normally happen is your crank sensor would go through this hole over here, through that hole over there, and then come down to your crank sensor over there. Okay, so that's this whole section over here covered. So what we'll do is we'll come back to the black plastic over here, and then coming out the back over here, you've got your earth strap which bolts onto there. Now these have an M8 hole, so in your case they go on this little section over here, but you do have an M6 hole and you can use either or, it doesn't make a difference. Then coming down here, you've got your Lambda sensor which goes through there. Now just remember, there is a metal shield that goes through there. You do need to refit that, otherwise the connector is not going to last very long with the heat of the exhaust sort of buffering against it over there. And then also coming out here, because this is using a J160 6-speed manual gearbox, we've got our gearbox harness, and there's our reverse switch. And coming over there, there's our speed sensor for the back of the gearbox over there. All right. And then moving along here, you'll see in the top here, we've got the harness that goes underneath the inlet. So that's going to your 2 knock sensors and your starter motor. We have rebuilt this one for the customer because he didn't have one on his existing engine that was there. So that's all new for him. And then you've got your main power starter cable which comes out over there, and that connects to the positive side of the battery. So that's the main power for the starter motor. All right, so I'm going to move around here now and come over to this side over here. So as you come further along here, you'll see there's a little breakout over here which goes to your other earth, which again can either clamp down to there or to the 8mm hole underneath there. That ring is capable of both sizes. Now in this particular case, the customer, I think the car originally was an auto. Well, judging from the wiring that we had inside the box there, he was complaining about a lack of speed sensor working. So what we've done is we've made him a little harness coming out here, which connects directly to the speed sensor at the back there. And what that means is that if we can't get the ABS system working for the Speedo, we do have a manual signal which we can then feed into the actual car and wire back into the dashboard itself. All right. Then coming along here, you're gonna have a breakout here to injector 8 and coil 8. Coming a bit further, you're gonna have a breakout here that's gonna go to your ACIS. So that's your ACIS over there. So we'll go for that when we do the testing. Then you're gonna have injector 6 and coil 6. Then you're going to come a little bit further along. Now normally what we advise is just use some P-clamps. You've got a mounting point there and you've got a mounting point there. But coming to this section over here, it's going to break out for your cam sensor for your right bank. It's going to be injector 2 and coil 2. Then you're going to come a little bit further and it's going to break out at the front here. That's going to go to injector 2 and coil 2. Sorry, I think I said 2. This is 4 and 4, injector 4 and coil 4 here. You're also breaking out for your coolant temp sensor, which goes inside there. Also breaking out for the oil control valve for the right bank, which comes out there. We're also breaking out for the mass airflow sensor. So in this case, we're using a 3UZ one. So you can see the wiring is different. So we just built a little jumper here to adapt from the 1UZ to that. So just remember, the 1UZ VVT-i has the much bigger mass airflow sensor. It looks almost like a bullet. And this is a 3UZ one, which is smaller. The wiring is completely different. So if you plug this plug into this one over here, you're basically going to blow up the inlet air temperature circuit on this MAF. So if you plug this into a sensor like this, you are going to fry the sensor. Just be wary of that. Then coming down here, we're going to break out again down here, and that's going to go then to your alternator plug over there. And then we've got the low oil level, which goes over there. Now again, this is a LS430 sump, so this is sort of rear / mid. On the LS, it's at the front, and so this oil level sensor would plug in down here. And then coming further along, we're going into your Lambda sensor, which goes into this one over here. Obviously, we're only using the 2 main Lambda sensors, not the secondary ones after the catalytic converters. All right, so that is the entire layout of the harness. So hopefully for Darragh, that's going to be really nice and straightforward when he comes to fit it on. You do have to, the only thing I would advise Darragh, when you're watching this, is when you take the inlet off to obviously do the sub harness that goes underneath there, what you can normally do is supply power to your ACIS. Now usually the white one is your 12 volt supply, and in this case they've swapped it around. So basically the white plug in here, that's your 12 volt supply, so that goes to the black wire. It might be different on yours, so don't take this as gospel, but basically there. So pin number 1 is 12 volts, the other one is a ground. If you just use a battery just to touch it on there, just to make sure that your vacuum solenoid valve for your ACIS is functional before you put everything back on, because it's going to be an absolute nightmare. And if this is not functioning properly, you lose a hell of a lot of download torque, which is not ideal. you didn't buy a V8 to have no low down torque. All right, so apart from that, it should be all relatively straightforward. You've got your alternator main cable, which we've all taped up and everything for you, and that's going to bolt into your fuse box over there. You've got your main starter cable, which you've got a nice long one, which is just going to go straight to the battery terminal positive, and that's the only thing you have to add on apart from all of your earths. And you'll see on the engine harness here, this is your earth terminal, which comes down to here, and then it actually bolts on to the chassis underneath the battery, and then it comes down to the earth, which is just over there, and you can bolt that literally directly to the bottom of the block. The only other earth that we advise you to do is to pick one of these, and I usually use the M8 hole for here. Then you can use the M6 hole, and you can just run earth straight from there to the firewall, and that should be enough earth. So you have the main earth going straight to the bottom of the block, and you have this one from the heads going straight to the firewall, and that should be all you need. Just make sure when you reattach all of this that you do clean the surface that this one is going on, especially because that's your entire earthing system for the entire chassis of the vehicle. That's the only place that that's getting earth from, so make sure nice and clean before you put that back on again so you don't have any issues there. Right, so yep, whole layout, really simple to obviously put in, and hopefully he can put it back in without any issues. What I'm going to do now is we're just going to do a bit of prep, and then we're going to come back and we're actually going to start it up and we're going to do some testing. So let's do that now quickly. Okay, so now we're ready to actually start it up and get it tested over there. There's going to be two parts of the testing. One is going to be stuff we're going to do without the engine running, and the other is going to be with the engine running itself. So to start off with, we're going to look at the charge light and the oil light. So obviously when we put the ignition on, you'll see the lights come on over there. Then we're going to look at the reverse light. So what we've done is we've put a little LED inside here. So this is the reverse wire that goes inside the vehicle. So as soon as I bridge that reverse switch there, that LED will come on, so that's fine. Speedo we can't test because we don't have the wiring inside the harness here to run directly to our cluster over there. Fuel pump, OBD2 test, so obviously we're going to use the OBD2 machine, make sure that communicates properly. Obviously we've made a little temporary OBD2 port into the body plug over there. Then we're going to test the fuel pump relay and the AC clutch relay, because those are controlled by the ECU itself. Alright, then we're going to move on to obviously starting the engine. So starter circuit, self-explanatory. What we're doing is basically we're cranking it from the STA here in the body harness. So this is imitating the power coming from the key switch itself, going through the whole system, through the neutral start switch wiring in the grey plug, and then coming back and activating the starter relay over there. Okay, I've put immobilizer there because obviously the Altezzas didn't have any built-in wiring for immobilizer, so we can't like make the security light work because his Altezza just won't have it and the wiring is not there. So as part of the starting procedure, the fact that it starts and runs, and you'll see it in the box already, there's no keys or anything in there, so we know that the immobilizer is successfully removed. Then we're going to look at the tacho. So because his was originally a 6-cylinder Altezza, by the looks of it, we're using a little gauge device which he already had, and that's converting the signal from a 4-cylinder to a 6-cylinder. So we'll see the tacho working on the cluster over there. Then we'll look at the coolant temp. So at the moment it's about 40 degrees, so it should be slightly peeling off the needle, but we'll go through the whole starting procedure. By the time I'm finished with all the testing over here, hopefully it's risen up above 40 degrees so we can see the needle moving on the cluster. Then we're going to look at the ACIS, so that's this little valve over here. So what are we looking for? We're basically looking for, this is in the open position. As soon as it starts up, that little valve is going to close down like that. So I usually do that sort of kind of after we start it, because this happens almost immediately after you start it. But that's another thing we're going to look at. Then we're going to use the OBD2 machine to test the 2 oil control valves. So what it's going to do is it's going to retard the cam timing, so it's going to sound like a big lumpy V8 for a few seconds while we do the test. That's just proving that both oil control valves are wired correctly and working as they should be. Drive-by-wire test, so that's self-explanatory. Because it's drive-by-wire, we're just going to turn the accelerator pedal position sensor over here to make sure that it's revving from basically the initial movement and not only when we yank it all the way through over there. Injectors and coils, nice and simple. What we're going to do is we're going to unplug each coil at a time, and that's going to then show us that each cylinder is misfiring as we go along. Then we're going to look at the codes. There are some codes that are permanently on there. It does have an automatic transmission emulator fitted on there, so pretty much all the auto gearbox codes are gone. There's just 3 left, SLU, SL, and SLT. Don't cause a check engine light and don't cause it to go into limp mode. Obviously you'll see the codes for the secondary Lambda sensors. Again, in this particular model, like the early 1UZ VVT-i's, the LS400s, 98-2000, it doesn't cause a check engine light and it doesn't cause a limp mode. This is European models, so please be careful. If it's US, there's going to be differences between the different ones, but Japanese and European, no dramas whatsoever. All right, so first thing I'm going to do is it's a bit of a jumbled mess, but as you can imagine, we're trying to replicate an entire interior of the car here. So what we're going to do now is I'm going to effectively put the ignition on by bridging this wire in here. So I'm using the original feed that came from the actual, that power that goes to the key barrel. I'm then just looping it around and putting it back to ignition. So now you can see we've got the check engine light on the dash, we have got the battery light, and we've got the oil light. So we know that those are all communicating, especially the oil and the battery light, they're communicated via MPX. So we know the MPX device is working as it should do. So we've gone charge light, oil pressure. So what we'll do is we'll go into reverse now. So again, what we're looking for basically is this LED to light up, because we've got the reverse wire here, and we're just giving the other side a ground because the reverse gives it 12 volts. So I'm just going to come around over here, and we're just going to bridge the reverse switch. Okay, so I've just bridged the reverse switch there. I'll have to get rid of my little helper light, yeah. But you'll see there, the LED is now on. So again, super happy with that. So I'll just pull that out of there. That's all groovy. Okay, so it's reverse now, speedo, OBD2 test. So what we're gonna do now is we're just gonna go into the OBD2. I do apologize, I've already been in here, but because the way we've done this, it's got an ignition feed rather than a permanent feed. So we just have to wait for it to go through, but straight away you see it picks it up as an LS400. Obviously it's 98 onwards. And we're just going to wait for it to read the ECU. While it's doing that, oh no, the next test of fuel pump relay and AC clutch. So let's just let this go through its motions. Yeah, it's not the fastest machine on the planet. Right. There you go. Right, so we want to go into the engine itself. And so the first one we want to test is the fuel pump relay and then the AC clutch. So what we're going to do is we're going to go into active test down here. Let's see if I can just move this light out the way. Right, so first one we're going to do is fuel pump. So you'll see it's fuel pump, relay, and fuel pump. I do have a video, which I'll just stick up in the top corner here, explaining how these fuel pump systems work and why it looks like you've got a fuel pump relay and a fuel pump. That video will explain everything in much more detail for you. So I'm going to go into the active test for that. All right, if I press the right button. Right, okay, so as I do this now, you're going to see there's a circuit opening relay over here that's going to click. So as I do this, boom, you can hear the relay click. And you can actually hear the fuel pump in the background. It's in our professional tank over there. Right, okay, so next up we want to go and do the AC clutch. So all we want to do is make sure that the ECU is controlling the AC clutch. So bearing in mind with the AC system, you need to have everything else wired up correctly. So you've got a pressure switch at the front that'll make it work. If that's not wired up correctly and you have no pressure, obviously it won't work. So we're just testing to make sure that the actual signal coming from the ECU to the car to tell us to turn on the AC clutch is working. And 1, 2, 3. Okay, so hopefully you're going to hear it. I'm just going to move the camera closer, but it's in that little relay box by the ECU box over there. So hopefully you heard that. So that's the AC magnetic clutch relay working. So we're happy with all of that. Go back to data list. Right, so what we're going to do now is we're going to start it up. So that's going to do, first thing we're going to do is obviously start a circuit in the immobilizer. So if it starts up and it keeps running, we know the immobilizer is removed and we know the starter circuit works absolutely fine. We'll go over to the tacho. We'll come back to the coolant temp sensor. We'll probably go straight to the ACIS to make sure that's working. We'll do the oil control valves. We'll rev the engine up on the accelerator position sensor. We'll go through the injectors and coils one by one, and then we'll come back and look at the codes. So first thing I need to do is get my ear protectors on. Right, so again, we're just mimicking the start signal coming directly from the key. So as we do that, and we're showing about 52 degrees, so that is absolutely fine. What we'll do is, while it's running, quickly access these codes over here. All right, and what I'm going to do is I'm just going to briefly remove the fuel pump so we can cut the motor off while keeping the ignition on. So that. Okay, so it's just so I can keep the OBD2 machine alive so it doesn't cut off. So I've just removed the fuel pump to get rid of the fuel. So as you can see, your little fuel pulsation dampers over here. If you notice in the other video, you'll see this rises up as you have fuel pressure. It's a really good indicator to see if you've got fuel pressure actually at the rails. That's always a good way to look. If you're not sure why it's not starting, good place to start. Right, so codes that you are going to get, right? So this is your bank 1 sensor 2, bank 2 sensor 2. So that's your 2 secondary oxygen sensors. As you can clearly see from when the engine's running, it doesn't cause a check engine light or a limp mode. And then down here, you've got SLU, SLT, and SLN. So that is the only 5 codes you should ever get. As is evident, I've run the motor on here. Everything is wired up like the automatic transmission emulator. So you should only ever get those 5 codes. Now, this vehicle obviously is equipped with an OBD2, so you can plug that all in. But there is another way of doing it. And effectively, if you go to the OBD2 connector, you can bridge pin 4 or 5 and 13. That's going to give you trouble codes like it's flashing the check engine light. Now, because we have those 2 codes, which would be 27 and 29, what I'm going to do is, this particular vehicle is, I think, prior to a 2001, because 2001, they actually removed these diagnostic ports that are on the fuse box here right next to the ECU box. But in our case, because we do have it, I'm going to show you how to do it here because we don't have a fully wired up OBD2 port. So basically what I'm going to do now is I'm going to come along here, and if I look in here, I'm looking for E1, which is in the top corner. So that's that bad boy over there. So that's our earth that we're going to use. Right, and then we're looking for, I think it's going to be, where's TC? Here, TC. So of this 3 row here, it's the one in the middle. So what I want you to notice is, as I do this, you are going to see the check engine light. Oh, I probably haven't got a ground on that one. Right, let's try and see. Let's try and see if I can get a decent ground. There should be a ground in that one. Yes, it just hasn't got any. Yes, I haven't got good connection on here. That is TC. No, anyway, do apologize. I think there's probably an earth we maybe missed over there, but that is how you would read the codes. What I can do is, if you look back at some of our other videos where the IS200 plug and play is, I actually show you when I use the half cut, how that particularly works. But basically the check engine light will go off and it'll start flashing. And what it'll do in this particular case, it would go 1, 2, pause, 1, 2, 3, 4, 5, 6, 7. That would be 27. It'll go pause, then go 1, 2, 2, pause, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 29. So 27 and 29 are those 2 codes up there. So that is just like a generic way of reading the codes without having to actually have an OBD2 machine there. But in your particular case, Darragh, you should have no check engine light unless there is actually a genuine issue with the engine. So if you do have a check engine light, don't tape it up. Either read the codes via using that box over there, exactly like I showed you there, or bridging the 2 terminals here, which sometimes is easier, but it's in the driver's footwell facing down. It can be awkward to get to. Then you should be able to read the codes. There's a second thing that that does, which some people may find very useful, and that is once you put it into that diagnostic mode, which is what happens when you bridge ground to TC, what also happens is it locks the timing at 10 degrees. So if you have a look on your crank pulley down here, you've got 0, 5, 10, and 15. So what you can do is, if you've got some weird rough running or anything like that, and you just want to check the timing just to see if the electronic timing of the ECU matches what you see on the engine, to make sure that one of your cams haven't slipped a tooth or anything like that, you basically grab a timing light, coil 1. Now I have a Sealy timing light, and it works just by clamping onto the wires. If not, you can pull that coil out and you can basically take an old actual spark plug lead, push it down in, go through there, and then wrap that around your timing light clamp, and you can check the timing. All right, so then you should see 10 degrees. If you're seeing 12, 13 degrees, then more than likely one of your cam have actually slipped a tooth. All right, so you can see that's out of thing. So again, it's a very nice way to diagnose weird issues that you might have on there. Okay, so, and that makes it more importantly, don't leave, if you do bridge that to either read codes or check the timing, don't leave that in, because you are locking the timing at 10 degrees. Even if you're at 6,000 RPM, it's got 10 degrees of timing. So again, don't leave it in. It's going to be a really, really horrible drive if you do so. But next thing up for us is to get this all boxed up, get this off to Darragh, and let him have the mammoth task of refitting all of this into the vehicle. So if you guys do have a particular vehicle, and the pictures that I showed much earlier when we were doing the build process, I'll show you, there was photos of what it looked like originally. So if you guys have a situation where someone has already been in there and messed around, because remember, our plug and play harnesses rely on this interior harness being completely stock standard. We're relying on the wiring in there being correct so that we can obviously work from that interface. If you guys have people that have messed around already, maybe cut the plugs, try to repin it themselves, and so on and so forth, and that, we do need the whole entire interior harness to do that. So it can be done. It's not the end of the world, but again, international guys, you know, sending all of this stuff maybe from America or Australia or wherever it is, probably going to be quite expensive. So just bear that in mind, that when you guys do want plug and play harnesses, the ECU box you see there and the interior harness needs to be stock standard, because we are relying on that for our patch harness to interface with the car. If anything is changed on there, then our plug and play harnesses won't work. All right, but that's it, guys. If you have any other questions, please feel free to ask. If you want, put some comments down below, or if you want a faster response, you can message our Facebook page. My wife monitors the messages, so she'll get back to you, and any technical questions, obviously, she'll pass over to me to answer for you guys. But thanks for watching, guys, and we'll see you again, well, in a bit, because we've got that 1UZ that's running ECU Master, so that's coming up next. All right, guys, so we'll see you soon. Bye-bye.